As we continue section 2.1 on page 4 of your lecture notes, we're going to talk about how to solve first-degree equations. What a first-degree equation means, remember from a couple of weeks ago, is that the exponent on the x is going to be of the first degree, or it'll be an exponent of 1. It will not be an exponent of 2 or 3 or anything else. Those are solved in different manners. These are for variables with an exponent of 1. The first thing that we're going to do is simplify the equation using the please excuse my dear Aunt Sally rules and removing any grouping symbols that are there. The second thing that you do is collect all like terms, and if we remember back to the third week, like terms means that if you cover up the coefficient, then the rest of the expression is identical to another one. So if it has an x and a y, the exponent on the x and the y must be the same on everything that's alike. So again, if you cover up the coefficients and everything is exactly alike, then those are like terms. So what you do is collect any like terms that there are. That means that add all the x terms together by adding together the numerical coefficient that does not increase the exponent. It stays a 1. And if there are any numbers on the same side, then add those numbers together. On step 3, we're going to add or subtract variable terms to get all the variables on one side. On step 4, we add or subtract numbers to get all numbers on the opposite side of the equation from the variable terms. 3 and 4 are actually interchangeable. You can do those in either order. Step 5, though, has to come after steps 1, 2, 3, and 4 are done. And this step occurs when you have one variable term on one side and one number on the other side of the equal sign. There will be two terms, one variable term and one number. They'll be on opposite sides of the equal sign. At this step, you divide each side by the coefficient of the variable. Like if you have 6x is equal to 12, there's a variable term on the left, a number on the right, so you divide by whatever is in front of the x. In this case, it's a 6. So we divide both sides by 6, and in this case, we would get x would be equal to 2. The last step is to go ahead and check the solution to your equation. Let's take a look at an example. Let's look at the equation 6x minus 5 is equal to 2x plus 3. This equation would be rather difficult just to look at it and try to figure out what the answer is without doing a little bit of work. The first thing we want to do is identify what's a variable term and what's a number. So 6x is a variable term because it has an x. Negative 5 is a number. 2x is a variable term because it has an x, and 3 is a number. Our first step was to simplify things using the please excuse my dear Aunt Sally rule and get rid of any parentheses. We don't have anything like that on this problem, so we don't have to worry about step 1. Step 2 is to combine like terms that are on each side. This one we don't have to worry about that one either, because on the left-hand side there's only a variable term and a number, and on the right-hand side there's a variable term and a number. There's nothing on one side or the other that we can go ahead and combine. So what we want to do then is get all the variable terms on one side and get all the numbers on the other side. On your lecture notes, what I did is I retyped some things, so you probably want to take this equation and move it over. So we want to take this 2x that's right here, and we want it over here on the left-hand side because I get to decide where I want my variables. And on this equation, I decide that I want my variables on the left and I only want numbers on the right. I could have chosen the other way, but this time I want all variables on the left. So that means that I need to get rid of this 2x. It doesn't need to be on the right-hand side. The negative 5 is over here on the left. I only want variables on the left, so I need to get rid of this negative 5 from the left-hand side. So let's go back and look at it again. The 6x stays because it's a variable and I want variables on the left. The negative 5 needs to move because I only want numbers on the right. The 2x needs to move because it's on the right and I want all my variables on the left. And the 3 can stay. There are two different ways that you can work the equation as you go through the different steps. The first way that I've labeled way 1 is where everything is worked out going straight across. I've underlined and put in italics the things that are moving or the things that are added or subtracted to each side. So it's easy to look at it and see what's been added or subtracted to each side. The second way is the way that I actually prefer to work the problem and go through. They're both the same exact way of doing it, but I think the way on the right is possibly a little bit more clear. So we start with the equation that we had, the 6x minus 5 is equal to 2x plus 3. We knew that we need to get rid of this variable here. So in order to get rid of it, we need to take its opposite and add that to both sides. Its opposite is a negative 2x. So we're going to add a negative 2x to the left-hand side and to the right-hand side, or we subtract 2x. They're both the same thing. So we have an equation. We're going to modify it. It's not going to look like it did previously, but we're doing the same things to both sides. It was like on the first problem that we had when we started this chapter, where we told two girls to get off of each side. Here we're telling two x's to get off of each side. So we're going to go ahead then and off of each side get rid of two x's. So we've done the same thing. So we draw our line and we go 6 minus 2 is 4x. The negative 5 comes down because we haven't added or subtracted anything to it. 2x minus 2x gives us 0x, and 0 times anything is 0, so it goes away. And we bring the 3 down because it hasn't been added anything. The other thing that we wanted to go ahead and get rid of is this negative 5. So in order to get rid of this negative 5, its opposite is a positive 5. So we're going to add 5 to both sides. Again, we're doing the same identical thing to each side, so we're being fair. And as we go through it then, we're going to draw our line and add again. There isn't anything added to the 4x, we bring it down. Negative 5 plus 5 gives us 0, so we don't need to write anything over here. 3 plus 5 is 8. At this point, it's worked the same on both sides, so we'll go back over here to the left-hand side where we have the 4x is equal to 8. At this point, we get to step 5, and that's where we have two terms, one variable term and one number term. At that point, we always divide by the coefficient of the variable. The coefficient of the variable is a 4. We divide both sides by 4. 4 divided by 4 gives us 1, so we just have x, 1x on the left. 8 divided by 4 is 2. So reviewing again, what we've done is that we have added or subtracted the terms in order to get rid of them on each side. So once we identified the two terms that needed to move, we added the opposite of the negative 5, and we took the opposite of the 2x and put that on both sides. Once we did that, we got down to the point where we had two terms. At that time, we're ready to divide. We're always adding or subtracting until we get down to the point where we have two terms. Then only then do we divide. Finally, our last step was to go ahead and check our answer. So we want to know if x is equal to 2 is really the answer to our equation. And we do this just like we did for the last couple of weeks. We use substitution. We replace every letter by a set of parentheses. So on the first line you can see where the x got replaced by a parentheses, and then you take the value of x and put it everywhere where you had an x. So there's one there and there's one right here. Then you go through and use the please excuse my dear Aunt Sally rules again. So we have 6 times 2 is 12. 12 minus 5 is 7. 2 times 2 is 4, and 4 plus 3 gives us 7. So it checks. So that means that we're confident that x is equal to 2 is the answer to our problem. If the two sides did not check, if we got something other than 7 is equal to 7, then we need to go back and either recheck our math on the problem of doing the check, or we need to go back and really see if x was equal to 2 is really the answer, or if there was a mistake somewhere. At this point, you may want to pause the video and go back over the last problem and see if you can work it on your own without having the work there for you, and go back through and check it. We'll take back up on the next video and go through this next example.